Okay, now we're moving into the first plenary session with a keynote speaker. So my name is Nostbakken, and it's a very great pleasure to welcome you all to this keynote. We're fortunate to have Professor Robin Burgess from the London School of Economics with us. In addition to being a professor of economics at the LSE, he also serves as co-founder and director of the International Growth Center, and he leads the Economics of Environment and Energy Research program there. Robin is internationally recognized for his work in environmental economics, development, and political economy. His list of accomplishments is very long, but to mention a few, he co-directs the COAST project on the economics of climate, energy, and the environment, and he's a fellow of the British Academy and the Econometric Society. He has published extensively in the very top journals in economics and is the recipient of 2 prestigious advanced ERC grants. His most recent one, I noticed, has the same title as the keynote lecture today. So today he's going to speak to us on, I would say, topics that are both timely and urgent, as we also touched upon in the previous session here: innovation and the environment. So Robin's talk will explore how innovation is shaping 3 important areas: clean energy, climate resilience, and conservation. I'm, for myself at least, very much looking forward to this. So Robin, I'm not going to take up more of your time. Thank you for being here. The floor is yours.
Okay, thank you. Welcome, everyone. And thank you both to the head of the NHH and the current and future presidency of EAERE. I'm going to start by just saying a few things about the sort of, for researchers, it's interesting to see how research was begun, where it came from, and why it happened, particularly for younger researchers, to sort of figure out how to. So I think the first thing, the kind of origins of this lecture was a very long train ride with Ben Groom to Exeter, where he told me all about this conference and this grouping of people. And I'm somebody, like many of the ones who are working with me, who have come into environmental economics, not super recently, but in the last, I didn't start in environmental economics. And I think that that's an important fact, because many of the projects I'll be discussing are about people from different areas of economics now recognizing how important environmental issues are, and then using different methodologies, different data, different theory to kind of probe those issues. And I think it's kind of enriched the whole field, and is also part of what I would describe as a kind of mainstreaming of environmental issues into economics, and and perhaps even more importantly, into economic policy. So it's no longer a sort of a set of issues that is of consideration in ministries of environment. It's in the ministries of finance, it's in the central banks, it's in the planning ministries. And I think that's to be welcomed, because the set of issues is now so important that, so for me, what basically happened, as I came up I was originally a biologist, so my first degree was in biology, and then when I did my PhD, I moved into development, because I'd grown up in Uganda, Malawi, Tanzania, and the Philippines, so I had that sort of set of interests. But about 20 years ago, when I was visiting Berkeley, I met Michael Greenstone, who, like me, he was coming from public and labor, I was coming from development, and we started working together. Around the same time, I met Ben Olkin when I was visiting MIT, and we started working together. And then for a long time, I've been working with Oriana Bandiera, who is also coming from development. But what's interesting there is none of those people, the sort of senior members of the research team, none of them identified as environmental economists. Now, increasingly, they do, particularly Michael. And I think that's a sort of a fact that all the young members of the research teams that I'm working with all identify as being environmental economists. But there's a set of people who, I guess, like me, have sort of come into the field. And I think that's a kind of, it's been a good thing, because hopefully, with time, every economics department will want to have 1 or 2 or 3 environmental economists working in their faculty, like what happened with development economics. So for development economics, the kind of clarion call was ending extreme poverty. That's what everybody came around. It was macroeconomists, microeconomists, and lots of people from other disciplines working on that. And obviously climate change, if anything, has an even bigger draw, right? Because it's global, it involves all types of economics, involves many other disciplines. And so I think this is a sort of a fantastic time for young people to be entering into this field. And at the LSE, we've had, from 2000, when there was a kind of reading group started, an increase from about 4 PhD students in the Department of Economics to about 25. So in 5 years, about, I don't know what that is, quintupling of PhD students. We've started a PhD course in environmental economics, having never taught anything in the economics department, and an undergraduate course. So if that's happening at the LSE, it's also happening in many other departments. It's happening in geography departments. And so I think this is a sort of a time where a few people, like at the LSE, a major factor was Claire Balboni getting a job at MIT Economics, and then that drawing in many other PhD students who wanted to work in this area. But now it's a whole community of people, and then they organize LSE Environment Week, LSE Environment Camp. So it's an exciting time. So let me begin with the sort of content of what I want to speak about, which is these 3 areas. So I will be, the way I like to present this stuff is mainly, I don't like words very much, so I'll just do mainly maps and figures and so on, but hopefully you'll get a flavor of what's inside. These are all 3 projects which are ongoing. One is not even drafted in any way. And I think what's interesting is that they kind of cover many of the areas that you discussed in your introduction. The first one is mainly to do with mitigation, the second mainly to do with adaptation, and the third mainly to do with natural capital. And if I have time, I'll end with a few words on a project I'm doing with Rohini Pandey for the COP30 president on reforming carbon markets. That's another example of a whole set of people coming in to work on issues that the Brazilians who are heading COP are interested in. Okay, so I guess the first point is when you look at these 3 projects, they're covering very, very different methods. So the first one is sort of structural modeling, diff and diff. The second one is development, it's an RCT. And the third one is doing I/O with lots of remote sensing data. So that's a kind of a fact, is like the number of methods coming into environmental economics is expanding as different fields of economics, as the different disciplines. For example, with remote sensing, a lot of that is not done by economists. A lot of the data generation processes are not actually carried out by economists. We're going to look at 3 countries, all important in different ways. So again, in line with the set of issues. And then these are the teams. And I think just peering at these teams, I've mentioned so Michael Greenstone, the origins of the first paper, then Michael's not on it, was we had an RCT in Bihar in India. I noticed all the panels are made in China. And I was like, how did that happen? And then we started working because we were closed at our houses during COVID. And we created the LSE Solar Lab, which is a set of people. So it's PhD students, it's pre-docs. And so the first paper is a kind of how on earth did China become so dominant in the solar market? What were the kind of policy instruments that were responsible for that? The second paper, which is with Claire and Oriana, again, this is a team that's been working in Bangladesh since 2007 with a huge NGO called BRAC, so a different partner. Here, most of the data we're getting from the first paper are the government or from commercial registries of firms. Here, there's an active collaboration with the NGO, evaluating through an RCT one of their programs. And the thing I'll present today is whether that anti-poverty program actually affected climate resilience, which is a completely new set of results which are just coming out now. And then finally, the one that's really much more vague is this sort of idea of smart conservation, where you think about, for example, in Indonesia, if you have peatland, which is high carbon, and you can grow oil palm in different areas, then would it not make sense to sort of protect the peatland and then allow oil palm growing to occur elsewhere. But the key thing we're going to be doing there is to compare the effects of a ban relative to a Pigouvian tax. And the idea that the political economy of it, those have different consequences for producer surpluses, i.e. for the people who are growing the oil palm. And so there may be different levels of resistance to different policy instruments. Because in the third one, what we're really interested in is, if you think about the original sort of focus of development economics as extreme poverty, that obviously can run counter to regulatory instruments that are constraining development. So then you need to find ways that you can get through politically, that are going to be politically feasible in these places where there's still development going on, while at the same time you're conserving as much of the carbon as possible. Okay, so let's start with this. So this is something also already mentioned. And I guess the thing that I would focus on is if you look around 2006, 2007, there's this acceleration in the fall of the price of solar. Obviously the magnitudes everybody knows. And so we're particularly interested, like we all know kind of that China's a dominant player in producing solar panels. What I was not aware of is it's also the dominant player in terms of patenting in solar panels. So I'm just going to show you a few maps, which I love, just to describe what happened in China. But before I do that, let me just show you a couple of things on prices of other sources, for example, of electricity generation. And you can see with this sort of falling yellow line just how special solar is compared to the others, including some of the renewables. And these are different projections on what would happen to solar. And basically, on the whole, solar's gone down, become cheaper at a rate which was faster than was predicted by many of the experts. So something was going on. And what I'm going to argue is that that's a lot to do with innovation happening in China. Okay? So this is between 2011, 2020 for China, 2008 and 2020 for, and you can see this, that there's been a huge increase in the rise of renewables. So one big source of kind of optimism is that we will decarbonize, for example, power generation, transportation, and that's going to be a huge part of kind of bending so that on the whole, the challenge right now is that you need to find cheap ways to bend the emission curves quickly. A lot of people think about permanent removal and so on. I actually think that you need to provide time for more innovation to take place in, for example, carbon removal and renewables and so forth. But right now, the real challenge is bending that curve, and that is particularly important in developing countries, right? So the kind of countries like China, India, Indonesia, South Africa, Brazil, because if you don't bend it now, they're the ones where the energy consumption is growing very, very quickly. Okay, and this is to begin just to sort of argue that China has become very dominant. So this is the share of cell production, solar cell production. You can see, for example, the US just collapsing as China takes off. So this is the production side. This is the also production where the top line is the world. It's basically tracking China. This is actually exports, again, the same story. But this is the one that's more interesting. So this is patenting. And you can see here in solar patenting, China's just become the dominant player. Now, of course, you may argue that some of the patents in the Chinese patent office may not be as valuable as a patent in the European patent office or the US patent office. But nonetheless, the kind of overall trend is stunningly positive, right? Okay, so I didn't know all of this, but I kind of got to know all this. And then we started working with John and this team during COVID because we had all these pre-docs and PhD students, and we were all trapped in our houses. And what we did is basically we had this genius PhD, so then pre-doc, now PhD student called Yifan Wang. And Yifan worked out that you could both find every solar manufacturer in China, and you could link them to the patent office, the Chinese patent office, and hence to the international patent offices. And you could link them to the export data, so actually from the firm. And so what we started to do is to sort of figure out, like, what were the Chinese doing? We did lots and lots of reading about Chinese policies. And Chang Tai-hsia, who's at the University of Chicago, who's somebody who sort of wanders around China, knows it very, very well, was telling me that the key thing about China is firms form relationships with city governments. They do that for many reasons. One is to get land, one is to get capital, and often to get access to skilled labor forces. And then they compete. So it doesn't have to be solar. It could be like producing aluminum or producing chips or producing beer, for that matter. And so you get these clusters of industries which form because city governments are sort of incentivizing them to come into their territory. Okay? So we started thinking, okay, and then there was this data set called PKU law that lists, I think since 1949, every Chinese policy at every level. So we managed to pick up all the solar policies that took place in China and link them to different cities. And there's basically three types. There are demand subsidies, which are like feed-in tariffs. You pay to get more solar electricity produced in your jurisdiction, your city jurisdiction. Then there's production subsidies, where you pay often per megawatt to produce more panels. And then there's innovation subsidies, which are always on top of the production subsidies, where you pay to have an R&D lab in your firm to increase the efficiency of production. So we had all of these, and they come in at different times. So what I'm going to do is to show you in these amazing maps, like what happened in China. So here we are in 2001. This is not production, this is patents. So the deep red is between 1,000 and 2,500. And you see in 2001, there's not a whole lot happening in terms of solar patenting in China. But as we move through, you start to get a bit more. And then 2007, you see the black blobs appear. And the black blobs are subsidies in that city region, okay? Of any type. Could be demand, could be production, could be innovation. But what's interesting is that we move through time, there are just vast amounts more patenting going on. But we know in each period who's subsidizing and who's not. So of course, you're all seeing this is going to be like a diff and diff framework, where you're getting introduced at different times, and then you want to see whether that, from an industrial policy sort of vantage point, you want to see, does it go up relative to the places where you don't do the subsidy? But importantly, you want to see if it stays up. Right, so once you introduce that, do you have a kind of a permanent sort of comparative advantage in the patenting or production or export of solar panels? So what I think is staggering is just the sort of change in this industry over this period between 2006 and 2020. And that explains why, for example, China has become so dominant in patenting and in production of solar panels, right? So the paper we're working on now, which is a much more tricky paper, is to write down a kind of macro structural model of the world to think about diffusion, because diffusion is more difficult to look at. But in terms of the China story, what I can show you now is the diff and diff plot. So this is now, we line up all those black blob introductions, and then we look at patenting for any type of subsidy. And you see that in the cities where it was introduced, it goes up and it stays up. So if you introduce a subsidy, you get this sort of permanent advantage. And then when you break it down by type of subsidy, you see that it's basically being driven by the production and the innovation subsidy. Okay, so it's basically those, because the demand subsidy is just a feed-in tariff. You don't have to, there's no local content, so you don't have to take the panels, they don't have to be produced in that city region. So we see effects on PM2.5, on CO2 from the demand subsidy, but in terms of patenting, it's the production and particularly the innovation subsidy that's driving the effects. And then we can sort of go through the same pattern for firm count. And again, this is where Yifan was amazing, just like scraping every type of data in the world from China putting it together in this big, basically a city panel. And then here for panels, so this is in megawatts of production, the same pattern exactly. And then important for the rest of the world, exports. So again, those cities that introduced a subsidy were more likely to export, and it's the same pattern in terms of it's the production subsidies, innovation subsidies that are driving that. Okay, so now we've done all that. That's kind of fairly standard. I mean, it's genius data gathering, but it's a fairly standard applied micro paper at this point. You know, fancy diff and diff, blah, blah, blah. But this is even more interesting. So we build a structural model with the different sectors. And I won't go into the detail of that, but this is showing you basically that had you had no subsidy, that would have been the price fall in China. The green is what happened as a result of the subsidy. And the black is what actually happened in the world. So the first figure we saw. And you can see that the Chinese, just the city-level subsidies, and this is the dominant area of subsidization in China, can explain 40% of the fall in solar prices in the world. So this is, I guess, pointing to the fact that typically, and I'm no expert on COPs, I've been to a few, but I'm no expert. You know, that's how we often think about international agreements as a global problem. But actually here, one country, unilaterally basically, and to make money, is doing things that are probably going to be at least in price terms, very, very good for the rest of the world. And it kind of shows you the innovation part of this, whether it's the US, EU, China, or indeed perhaps India increasingly, perhaps Indonesia, are going to have big effects on the rest of the world because they're affecting products which are going to be part of the decarbonization process. So this innovation part, I think, innovation and diffusion part requires a lot more attention because it's a big part of what actually is happening now. Okay, I'll be brief on, so this is again from the structural model. The only interesting thing here is you can see that there's big welfare gains from the actual subsidies that took place, and then the equal one is we just distribute the subsidies equally across cities. Doesn't look like you gain or lose very much there. But the interesting one is the third one, because in the third one, the area below the red bar is just allowing all firms to give them enough money to all do innovation, and then redistributing the rest of the money, which is the area above the red line, to the demand and production subsidies. So the message here is that subsidization of innovation has a much bigger effect on welfare than the other forms of subsidy. So it's really this kind of getting better panels, more efficient panels, lower price panels moving. And then we introduce the social cost of carbon on the right, and because we're reducing emissions, that's having an additional effect, and you get a substantially bigger welfare effect. So these are not small effects, these are big effects from the introduction of this industry in China over a fairly short period. So we're talking about 14, 15 years. On diffusion, it's trickier. So this is a picture of just graph out installed solar capacity and solar potential. And unfortunately, we're installing the solar in areas with lower solar potential. Now, we're looking into why this is the case. Obviously, there's factors like, do you have the right types of firms? Can you underwrite these large investments in solar parks? There's also quite big difference in installation costs. But this is the big story for the world because obviously China just doing a lot of solar and it going around to the US and the EU and so on. We need this to happen in those countries which are now shooting up in terms of their emissions. Indonesia's, the India's, and so forth. So this is basically what we're working on now. The same team, more or less. And I think it's a huge area to work on because this doesn't make any sense from just a sort of physics point of view. You'd want to put the panels where you get most energy out of each panel, and that's not happening. Okay? Even if you level up by GDP, it doesn't look upward sloping, it looks flat. And then this is just some graphs from the US, which are interesting. So you can see China, so 2008, price of solar panel just collapsing. And that's the China, whatever you want to call it, the China shock, the China solar shock. But interestingly, if you look at the yellow line, which is sort of the soft cost, installation, financing, and so forth, that's also falling, presumably because firms get better at putting these in, they get better getting access to finance and so on. So there's some, it looks like there's some learning by doing as you install more panels. But we don't really have these pictures for every country in the world yet. We're sort of working on that. Okay, so, but exhausting. Let me talk about adaptation for a little bit. So, how do I do this? So I guess the big thing is, if you look at the world, so let me just show you one picture of a couple of maps. So one picture is, so if you look at what me and Oriana have sort of focused most of our career on, extreme poverty, it's basically in Africa. This is sort of the $2-point-something a day below that. And it's in South Asia, India, Pakistan, Bangladesh. That's mainly, a little bit in Latin America, but extreme poverty is in those two places. And then if you look at Michael and Tama's paper in the QJE, which I'm sure all of you have seen 3,000 times, all the damages are exactly the same places, right? So that's the really big one in terms of the sort of adaptation side. It's the fact that the places which are being most damaged are precisely those places which never produced the problem in the first place. Now, of course, India's having a damn good go at doing more and more emissions at the moment, but there's this huge question, right, of how do you protect people? So that's the sort of second area of innovation, is how do you rethink innovation policy so that people are actually taken out of harm's way? And I think the core insight that sort of have formed in Oriana and my brains and Claire's brain in the last 5-10 years is a lot of it's about occupational change. So if you're in the worst occupations, and I'll be brief on this in Bangladesh, but that's what we're going to be talking about, then you're buffeted by these shocks. So for example, if you're an agricultural laborer without land and you're working on a daily wage rate, the wage rate may fall or rise according to what the weather patterns will look like, but often you can be thrown into unemployment if nobody wishes to employ you. So let's say there's not much demand for labor, you have no security, and then you have no non-agricultural income, you have no assets, you have no savings, and then you're really being damaged in terms of malnutrition, mortality, and so forth. So looking at this map, you can see how acute the problem is. And I'll be brief on the sort of background of how we got to the current paper, but this is a picture from India in a paper with Dave Donaldson and Michael Greenstone, just showing that the effects in India of the same temperature, this is all the way from 1957 to 2017, the effects of the same temperature variation are much higher on mortality than they are in the US. So in other words, the same weather variation is having a much, much bigger impact in India. And if you look at that by rural-urban, it's all rural. Okay? So we're going to now look, and this is also saying, well, we've made some progress in poverty, but actually when you look at the areas where the poor are, this is Africa on the bottom and Asia on the South Asia on the top, there's still a hell of a lot of people in extreme poverty, and it's not going down in Africa. Right? Obviously, the population's going up, so the proportion may be going down, but the absolute numbers are not going down. Okay, so let me very quickly introduce you to the setting. So we're in rural Bangladesh. It's 2006. I'm running around in some Jeep trying to interview women about this program called the Ultra Poor Program, or the graduation program. And eventually we convinced BRAC to do their first RCT in 2007, looking at what happens when you do this program, which is essentially a combination of giving out assets and training on how to use those assets and social support for 24 months. But then it stops. So it starts in 2007, stops in 2009. And the setting is that you go to a village, you get everybody under a tree or something, you draw things in the sand, and you produce these little business cards that identify a family, and then the community decides which of these bins do people fall into. So the ultra poor, you can see, this is women in each of these classes, which are the target of the program. Ultra poor women basically do these very, very itinerant jobs, maid, agricultural laborers. Richer women basically do livestock, mainly cows. And the livestock they have for the ultra poor are mainly chickens, goats, that kind of stuff. So these are very insecure people. And the way to see that is if you look at assets, so this is land, any kind of productive assets, these are assetless people, right? So what you're doing is you're transferring an asset in an attempt to push them into the occupations that are being done by the women in the middle and the rich. And what we're interested now is, did that impact their resilience to shock? So what we're going to do is basically have a long-running panel carried out with BRAC, and then using satellite data, superimpose shocks onto that panel and ask questions, are you made more resilient if you've got the program or not? Okay.
Why is it long run? Isn't that 2 years?
This is, what we're looking at is from 2007 to 2011, but the data we have is all the way to 2024. So there's different, but what we're using is essentially the period before 2014, where it's still a clean treatment control. Okay, so let me just show you what happens so looking at the first graph on poverty, this is the effects and percentages on the women who got the program. So nothing to do with shocks yet. So 21% increase in earnings, 11% increase in per capita expenditure, 57% increase in, in durables, and then these are the percentages on savings, livestock. So transformational, and the women who get, this is 4-year effects again, the women who get the program also start to acquire land. Okay, so this has been a huge thing for BRAC because now it's in, I don't know, 60 countries, a lot of governments are doing it. Last week, India announced in the Ministry of Rural Development that they're going to make graduation, which is this, a core part of their social protection program. So you can see the value of doing proper evidence-based thing in terms of convincing people whether something works. Okay, and then in terms of occupation and labor, what you're seeing is livestock's going up for the women who got it, ag labor is going down, maid hours going down, total hours actually going up, and total days going up. So this is driven both by the returns to animal husbandry being a little higher, but also working more. So this is all for women. And we wrote a paper a couple of years ago thinking about, what sort of view of poverty does this support? So this is sort of the solo version. So you sort of start anywhere and you'll end up in the top equilibrium. You may be, and then this is the poverty trap story. So if you fall below that dotted line, you fall back into poverty. If you rise, you go up. And this is a cute picture of that, which Oriana did. I'm not very good at this sort of thing. But in the solo version, you wouldn't have the red step. You would just step up to whatever level of productivity. Whereas here, if you, for example, don't have the money to acquire a cow, you're blocked from doing it. It could be the money to acquire a university degree, training, whatever. It doesn't have to be an asset. And basically, when we look at the data, this is what it looks like. So it looks very much like a poverty trap story. Now, we then use, and this is decadal, every 10-day data, shocks throughout this period from 2007 to 2011. And you can see in different periods you have lots, it's a very shocked place. And this is sort of showing the midpoints of the areas we're looking at. So we're basically drawing circles around these villages and then seeing what proportion of the pixels around them are either flooded or in drought. This is the result. So the key thing is that, so in the blue, you're looking at the women in this pure treatment control period who did not get the asset, right? And you can see that their per capita expenditure is falling. This is for a joint. So when you get an unexpected combined drought or flood shock. So clearly they're very exposed to these shocks. The women, at the very bottom, these are all ultra-poor women. But interestingly, the red is what happens to the women who got the program. And essentially they're largely unaffected, and that's also true for protein intake, okay? And then if we look at what's underpinning that, sorry, these were all done last night, so maybe not all correct, but this is for total assets. So again, you see for productive assets, things like land, anything to do with agriculture, people are divesting of those things and they're dropping, whereas the women who got the treatment retain those assets. And that's critical because then they're able to continue to generate an income stream from the livestock assets. And you can sort of see that here with savings and loans, that again, savings are being drawn down for the women without the program, whereas they're being held on to for the women with the program. This is the number of hours. So the women without the program are having to do less husbandry hours as they divest of assets and so forth, and more casual labor hours to make up. And then if you look at casual labor income per hour, so this is basically your income if you're, say, an agricultural laborer, it's falling a lot. And this is the sort of thing we're looking into now, is you just graph out in a village the share of assetless households and the wage. It looks like in places where there's more of a concentration, there's more women who are assetless. Or we have another measure, which I think is the next one, where the amount of land owned by the top 10% is bigger, then the wage is lower. So it looks like in places where there's more assetless women, they have less bargaining power. So the story seems to be like by getting the program and having an alternative source of income, you're able to maintain, you don't accept the super low wage when you get shocked. And that is one, because they continue doing some agricultural labor, that's one source of income staying buoyant. But the second one is you have this alternative asset, husbandry, which continues to generate income through the shock. And as a result, you're much more insulated from these shocks. And this is huge. These new results are huge for BRAC, because now in the world, which I'm sure we're all experiencing, where everybody's given up on development financing, and at least doing some climate financing, you can sell this program as a climate program as opposed to just an anti-poverty program. And obviously super important for those areas, Africa and so forth, which are even more affected than Bangladesh. Okay, I think in the interest of time, I will just move on to the last paper to give us time for some questions. But I wanted to mention just two things to sort of throw out some ideas. The first thing is that this is a data set that Oriana put together, which you can all access, called Jobs of the World. And if you think about it, what the Ultra Poor program is doing is it's adding an occupation for a very poor set of women, which they didn't have access to before because they didn't have the amount of money, for example, to buy a cow. It turns out they're perfectly capable of rearing cows, which is exactly the kind of opportunity view of poverty. It's not that we're poor because we're low ability or have bad traits or something. We're poor because we don't have the block of capital needed to enter that other occupation. That could be other, if you're looking at urban, that'd be more training or so forth. But if you just and this is just across the world, this is the number of jobs in these job censuses that account for 90% of the workforce. So it's kind of like job variety. And that's incredibly related to GDP, that fit. So it looks like if you think about a model where, let's say, I'm good at, which I'm not, but let's say I was good at designing the figures like the one Oriana did, and only raising maize is available to me, maize and cassava and a few other basic occupations, then I don't get to kind of match my abilities to the design job, because the design job doesn't exist. But if you move into a more developed place or into a city, then you get to match your abilities. And that may then lead to higher productivity because you're having this better matching between my set of it. So it doesn't have to be monotonic. We may be good at different things, but you just get, as you get more job variety, then you can match into different jobs. And this is the picture for the world, where you see like a lot of the countries in Europe right at the top, with lots of different types of choices of jobs. But interestingly, if you do it for Brazil, these are different micro-regions of Brazil, so the northeast would be down at the bottom. So there's only 20 jobs in the northeast that account for 90% of the workforce, whereas in somewhere like Sao Paulo, you'd be like 60 jobs. So in other words, if you're good at something and the job doesn't exist, then there's no match. But this is quite a striking pattern and suggests that some of the question around climate resilience may have to do with getting people into higher variety environments, often cities, where they can match these things, and also where they're less exposed to the damages. Because if you're in the countryside in Bangladesh, the stuff is hitting you all the time. So anyway, just an idea out there. But I thought these patterns are incredibly interesting in terms of thinking about, from a different vantage, how changing occupation and improving job variety could be important for climate resilience. Okay, so now we're into the super vague part of the talk. So this is something that's not written. We're sort of, we presented it in a short session at Stanford. But if we look at one thing I wanted to also mention, if you look at the set of authors in all three projects, so this is, again, with Ben Olken, I've been working with a lot, and Veronica, who's going to IIES, who's a PhD student of mine, all the young people, Francisco Costa, again, another PhD student, all of them are environmental economists. They love environmental economics. They're all identifying, they're all coming here. But all the senior people are all people who are just kind of coming into it because they realize how important it is. But I think what's also interesting is that you've got a lot of people like Francisco, who's in Brazil, and on the middle one, Munshi Suleiman, who's another PhD student, who's the head of research at BRAC. Two things: big numbers of co-authors. Big numbers. So these are labs, basically. And for labs, all these ERC grants and whatever, you can get your hands on, basically, constant grant writing, staff, doing grants and so on, are essential because they're expensive. There's a lot of in the middle one, two of the people are pre-docs, as PhD students. So that's the other thing, and then interestingly, very different people. So John, again, wouldn't naturally identify as environmental economics. He does a lot of stuff on innovation, but he's come into this because he's super interested. And then Oriana, the same on the social protection side, and Ben on the, I've done a lot of forestry stuff with, but again, he's sort of coming into the field. And I think that should be welcomed, but the key thing is it's looking more and more like natural science. These are sort of lab-based projects. They're expensive. There's lots of data. You need like hypercomputers to do everything. So it's a more resource-intensive activity than when I started. You like write a paper on secondary data in the library or something. Okay, so the final project, and I'll make sure we have 10 minutes at least at the end to finish, is on this area of conservation, natural capital. And I think what inspired me, so Alan Xiao, who was on the market a few years ago, who's at Stanford, he kind of had this in his job market paper. And what's interesting is that palm oil has more emissions, not every year, but often more than the whole EU. Why? Well, because you burn to create palm oil plantations, for example, on peat, you have to dry it out, drain it, dry it out, burn it, and so there's a vast amount. And I was thinking, wow, that's interesting, but this is what's really interesting. So this is palm emissions, and the dark stuff is peat deposits. So it's not the trees on top, it's the stuff in the ground, because they have this deep peat. This is Indonesia. So we started working on like how could you do smart conservation where you were sort of protecting more of the high carbon areas whilst allowing development to continue. And when you think about that, these are the areas of tropical forests which are very high carbon, the Amazon, the Congo Basin, Indonesia. But this is sort of what's interesting. There's always this tension between development of that land for national development. And remember that the emission costs are partly felt in Indonesia, but also felt all over the world, which Indonesians are not feeling, right? So there's that standard political economy problem. But you get these sort of endless sort of tension between the use of land for development, for example, by growing palm oil or soybeans or cattle or whatever. So we started to think about this, and we started to think about this question of how to navigate political challenges. And what sort of came out of that, and this is just super preliminary, is it actually makes quite a big difference. So if we imagine two types of instruments, one is a Pigouvian tax, and the other is a ban, that you just ban development in certain areas, for example, peatlands. And when you look at this, and we're going to just look at Indonesia, because in Indonesia we have, from Alan's work, all the kind of potential for growing oil palm and other crops. We also have carbon content. So then what we can do is we can graph out the domestic welfare loss as you do more of a carbon tax or a peat ban. And what's interesting, as we would expect, I mean, I'm told many, many times that one of the main problems with economists is that we always say, just do a carbon tax, don't be silly, this is what we should do. And that's sort of been very unhelpful, because if they don't want to do the carbon tax, then... And so here you see, you do get more efficiency with a carbon tax versus the peat ban. But interesting, if you look at producer surpluses, you're losing a lot less producer surplus in the case of a peat ban, because you can sort of pick out the areas where you grow the oil palm. And that's important because obviously the president of Indonesia can't go to the electorate and say, we're going to have a period of declining growth, but a lot less emissions. So you need to find ways, clever ways of regulation, which may not always be first best, which are politically feasible. And one of the things I think is maybe politically feasible is changing property rights, like kind of permanently, on areas of very, very high carbon value. Okay? So that was one last thing. And then finally, in the last 3 minutes, let me just mention COP30. So COP30, this is a report we're doing for the president of COP30, Correa del Lago, and this is the group. So one of these, Agnes is one of my PhD students, Lucy is working with Rahini, and Mariam's this like genius financial theorist. And what I wanted to say is that, going back to what was said in the introduction, I think it's really, really a question of urgency in terms of bending the emissions. And I can't pretend to know like what the best buys are, or I think we're in a world. I remember in development early on, about 20 years ago, sitting on a panel with Esther Duflo in Stockholm, and there was Bill Easterly, Jeff Sachs, and they all knew what to do. They were like, well, we do this, we do that. And I think development moved from that, of people who knew what to do, to people saying, we don't know what to do, but there's many different things we can try out and see what works. And I think environmental is very much in that phase where there's a lot of work trying to work out, because of course what you do in Indonesia will be completely different from what you do in Germany, say, right? But here I think the case for sort of focusing a little bit on developing countries is clearly one, the thing I've already said, energy demand is increasing most quickly, and climate change affects us all. But there may be arguments that it's cheaper to do these projects in low-income countries. For example, a lot of these forests are in low-income countries. Okay, so these are sort of 3 of the reports that we're doing. So the first one is with Patrick Bolton. It's all about decarbonization of the power sectors in emerging and developing countries. There's one with Catherine Wolfram, who'll be here tomorrow, who's looking at these sort of climate clubs between industrial nations, and then the one we're doing with Rahini. And just to finish, the problem here is clear, that if you look at this FT picture, the price of all these carbon offsets has fallen dramatically. There's two trust problems. One is poor transparency and low quality of credits, and then lack of trust in companies' commitments. So Agnes has actually written down a model where with offsets, if the Googles and so on of the world don't commit to reducing their emissions, then you actually end up with more emissions in the world because you buy the offset doesn't work. And so you just basically jack up the thing. So the result is weak demand and low prices. And what we're trying to do is to sort of think from first principles about a market design so that prices reflect the cost of high quality. So a big part of that will be doing measurement that you can argue that you are getting additionality in terms of carbon savings. And then you need to have some sort of binding commitments, like a compliance market for the northern firms that are buying these offsets. So they're actually already committing to reducing independent of the offsets. In which case you can end up with, if you just do the offsets without that compliance market, you end up with something like on the left, and the principle on the right, so the emissions coming from the global north decline and from the global south. So we're not pretending like we're not like COP experts or anything, but we are kind of people who are interested in market design, and we've been doing like lots and lots of reading about what's happened and then trying to work out from first principles what might we do in terms of reforming that market, and that hopefully something will happen in the COP30 thing when we all go there in whenever it is, November. I think I'll stop there. Thank you very much, and thank you.
So thank you so much. I think this was, at least to me, a super engaging use of graphs and maps with very interesting stories too. So I think this gave us a lot to talk about and also think about. We have participants online, so I just wanted to come up here to say that you can join the discussion if you go to this session on the ConfTool website. We'll pay attention and see if we can catch any questions there. But other than that, I'll let Robin handle the questions in this room, and I will wave if someone wants to join from online, and then we open it up for a discussion.
Who would like to start?
Hello, thank you, Professor Rubins, wonderful presentation. My question is simple: that as the paper one that you display in this seminar, and I want to know how to design your DID method by using which policy have you using to construct your DID empirical model? Thank you.
So maybe if I collect a few. And then I'll answer maybe in groups of 3 or something. So anybody want to, doesn't have to be about that, obviously. There's one up there.
Thank you very much for such an interesting presentation. My question is about your first paper. Well, I have 2 questions. The first one is about the clean energy paper. And how do you control for other type of policies like command and control and regulations at the firm level that there are some research as well proving or kind of concluding that they have even a higher impact than subsidies, and actually these kind of policies could be put in place in countries like China but might be difficult to implement in other countries. And my second question is more of a comment on something that you touch upon very briefly, which is this sense of more teams similar to natural sciences than economics, and the tyranny that we have or young researchers have in terms of publishing up to 5. If teams are more and more similar to natural sciences, interdisciplinary, should we just think in economic science to change the incentives and the career pathways of young researchers so they are able to be promoted in economic departments in more interdisciplinary or based in more interdisciplinary research than the one we are doing right now? Thank you.
Yeah. And there was one there, and then...
Yeah, you have argued that the Chinese subsidies have been very successful and welfare enhancing. I'm from Germany. Germany has spent a lot of subsidies, but feed-in tariffs, which you argued were not so successful in China. What is your view on the role of German subsidies for photovoltaics?
Okay, down here.
Thank you very much. Very thought-provoking, and thank you for the comment on interdisciplinarity and the lab structure of cutting-edge research in environmental economics, at least. I wanted to try to understand these subsidies in the China market. Are they only innovation, technological subsidies, or is it a combination of subsidies? Because trying to connect the two papers that I think have a connection underlying is, yes, it's important to innovate. Yes, the diffusion process is complicated and it's a function of innovation, but also grid, but also labor market skills.
Yeah.
So you need to find a way to boost the upskilling and reskilling, or even skilling in the global south, it seems to me, at least from my work, in order to make the argument that the global south could contribute effectively to mitigation processes. So thank you very much again.
Okay, so should I try those ones? And then, so first on the diff and diff, so we're using this Archkansky method. So we're lining up, depending on, lining up cities that look similar to the city that got the subsidy, and we tried many different methods. But in terms of the key thing, which is the policy, we actually have the statement of the policy, like for this city on this date, what happened. And going to the question you asked, the innovation policies are always on top of the production, so the innovation subsidies are always on top of the production subsidies, but they are specifically for R&D. Yep. So for R&D, what happens is that there'll be a federal inspector coming in and saying this lab in this firm is of a sufficient quality to get the subsidy. So what we have is the exact policy that took place in a city, and we also have some of the amounts of the subsidy, and so we can then match that to the panel, which is the firm panel in China, and show that those places actually did get these subsidies. So it looks like, but what's interesting, and I think this is actually really, really important, the UK is publishing, not this week it's the infrastructure strategy, next week it's the innovation strategy, is I think personally that innovation is massively underinvested in, because if I patent something, if going back to some of the more future things like carbon removal, we're not going to figure it out, right? We're not going to figure out how to do that unless we put a lot of sort of general subsidy money. So before Trump, and unfortunately probably not now possible, we were working a lot with the Department of Energy in the US, interested in carbon removal with Rachel Glenister. With batteries, they've been investing for years and years and years, and it's getting better and better. But you can't. That won't just happen with commercial incentives. So I think Europe, in particular, if we think about it, where did the Inflation Reduction Act come from? The Inflation Reduction came from China and the EU Green Deal. But I think now that the US is perhaps doing a little less than they were before, it kind of does come down to Europe to do a lot more in terms of innovation financing in all sorts of technologies, because there's no world in which, unless you decarbonize, the main sectors, you're going to get to that bending for the world. Because what we care is the world curve, not the Germany curve or the UK curve. On Germany, I think Germany was a huge boon, if you like, for China. You can see it in the data when they did where did all those panels, unlike the US figured it out, and they're like, you don't get any, unless you produce those panels in the US, you know, you don't get the subsidies. Germany didn't do that, so they all came from China. Now, if you take it from a global perspective, which is the paper we're trying to write now, I think probably the overall welfare improvement, if you add China plus all other countries, it was still probably good for the world that Germany did that. But there may be a need for Germany to be a bit smarter in terms of if they want to produce, say, like, I mean, let's face it, China's pursuing a green industrial strategy, not just in solar, in wind, in EV, in fuel cell, everything. If you want to compete in those markets, then you have to do the agglomeration. You have to have parts of Germany that are growing these industries. And I think there's more of a flavor of that now in Germany and in the UK and in other countries in Europe. But it's something which is difficult because the returns may not be in 4 years, right? And so it's difficult for a politician to sort of point to, I'm doing, I don't know, X million, billion for carbon capture, but you may not see anything for 10 years, right? So I think that's the sort of tricky part of it. But I think there's, as we were showing for China, the return on doing innovation so much higher than just encouraging the production of a particular good like solar panels. We probably have, no, I think we're probably at time, unless, do we do one more round, or? Anybody got a pressing question? Okay, I think, okay, sorry, there's one there, yeah.
Yeah, thank you very much. My name is Jan Stecker. I'm from the Potsdam Institute. I'm actually heading a lab on climate policy and development, so I have thought about these questions quite a few, and I would actually like to ask you on one of the statements you made, and I would agree that is something that is often put forward in the literature, that climate change mitigation is cheaper in the Global South. I would actually like to ask you for your thoughts whether this is actually true. Because, I mean, we are in environments with kind of a fierce political economy, with other market failures, with kind of, you mentioned the financing costs, etc., like high upfront costs, etc. So I wonder whether this kind of, you know, assumption that we often take so easily to be true, whether this is actually true, whether we can be certain, and would like to kind of hear your thoughts about this. Thank you.
Thank you very much. Last question. Okay, one more here, and then we should probably.
Thank you very much. Just to complete the question, I have in mind a specific example on solar project that have been investment in Morocco. I'm from Morocco. It was done by Germany, I think, and France. And there is a huge investment in solar energy as a clean energy, but it was done in the south, in an area where there is no water, and the technology needs a lot of water. So I was thinking about this idea of investing in the south and not thinking about unintended impacts that could have some other impacts on local people, competition on biodiversity, water, resources, and other impacts. Thank you very much.
Thank you. Okay, so I think I should probably answer the one on students and labs first, because I forgot to do it in the last round. So the way, you know, so for example, I have 16 PhD students, and they are all writing papers with maximally one other person, and always another PhD student. So the market now accepts co-authored papers as job market papers. But the papers they're writing are essentially building on these lab type. Not always. Sometimes they find something like, going to your question, as one student is working on AI centers and water and energy use from those. And for that, they've had to kind of find data in Chile, so they're completely off on their own, getting data. We know the Minister of Environment in Chile, so that helps, and they go out to Chile and so on. So there's connections, so that's one thing. But there's never more than 2 people on those job market papers. So they may be using the BRAC data some different way, using networks. So I think that's one thing, that they do have to, it's not an apprenticeship model that they sit there and then they hive off some little bit of the, they have to come up with their own idea, they have to develop that idea. But the second thing, which is very important, is different from the lab, is infrastructure. So if you're working, say, in Malawi or Uganda or whatever, just going there as a PhD student and working out, how to start a project is difficult. So many different types of infrastructure developed. There's International Growth Center, there's JPAL, there's those sorts of organizations that have offices in these places, and then you stage yourself. They kind of know how things work. They know about survey companies. So I think it is still incredible. What I'm saying is I think the fertility of work that is happening environmental is actually increasing dramatically because many different people are coming in. But it's more needful than just downloading secondary data from some place and analyzing that in Stata or something, right? So often you need some connections to a lab, you need infrastructure, and you need money. You need a lot of money. So you need often to have your own RAs. And so I do a lot of writing a grant, like it's me, that it's not me, and they get the money. And the LSE has become more accepting about PhD students applying in their own right without the supervisor for money, and that's been incredibly helpful. But I'm probably writing between 30 and 40 grant applications for PhD students per year to finance their work. And then the question about interdisciplinarity, I think my own sense of that is incredibly useful because you look at any issue like deforestation or, me and Ben tried to write our first paper on Indonesia back in whenever it was. We tried for 2 years. We had a PhD student, German PhD student called Stephanie Sieber. She tried to code the MODIS data, wasted 2 years of this person's life, and it didn't work. And so we had to bring in Matt Hansen and other people who were remote sensing people. And I think my own view of it is it's not like a dogma. It's not like we all have to be interdisciplinary because that's a requirement. It happens when it has to happen. And when it does happen like that, it's incredibly useful. And then finally, on the point about projects, I think you're absolutely right. The graph I showed you about installed solar and solar irradiance points exactly to these problems of, it's difficult to set up solar parks in poor countries, right? And so I don't think we want to assume that all the carbon projects are going to come from the global south. There are some advantages, cheaper land. Obviously, the project that we're doing with Rohini Pandey for COP is focused more on forests, both afforestation and avoided deforestation. But I think and that's obvious why, that's where the forests are. But I think for something like clean energy, carbon capture, all this sort of stuff, I think we want to be a little bit we don't know. And I think those problems of getting finance, underwriting, just massive. So if you're a solar park firm, I was recently in Zambia, they just won't touch it because they can't get the guarantees from either the guarantee from the Zambian government not worth a lot, and then it's very difficult to get the guarantees from the IFC or whoever, the DFIs, to get these guarantees. So I think you're absolutely right. The evidence right now is diffusion is much slower through the countries where, just from the physical properties of the panels or even of the wind stuff. So I think we need to set these things up where they'll actually remove carbon. That may not always be in low and middle income countries. Okay, I think at that point I should probably stop. Thank you very much.
Thank you.